Hello everyone. Today's experiment is chemical equilibrium, Chatellier's principle. Chemical reactions are represented by chemical equations. These equations typically have a one-way arrow to represent irreversible reactions. Reactions in which the reactants convert to products and where the products cannot convert back to the reactants. Many reactions such as combustion are irreversible. Other chemical equations may have two arrows, each with just half an arrowhead, the top one pointing right and the bottom one pointing left, that represent reversible reactions. In reversible reactions, the reactants and products are never fully consumed. They are each constantly reacting and being produced. A reversible reaction can take the following summarized form. This reversible reaction can be broken into two reactions. These two reactions are occurring simultaneously, which means that the reactants are reacting to yield the products as the products are reacting to produce the reactants. Unlike irreversible reactions, where the reaction proceeds in only one direction, a reversible reaction can go in either the forward or reverse directions. If a chemical reaction happens in a container where one or more of the reactants or products can escape, you have an open system. If a chemical reaction happens in a container where none of the reactants or products can escape, you have a closed system. Reversible reactions that happen in a closed system eventually reach equilibrium. At equilibrium, the concentrations of reactants and products do not change. But the forward and reverse reactions have not stopped. They are still going on and at the same rate as each other. Imagine walking the wrong way on an escalator, at the same speed as the escalator but in the opposite direction. Your legs are still walking forwards and the escalator continues to move backwards. However, the net result is that you stay in exactly the same place. This is an example of equilibrium. Chemical equilibrium is a state in which the rate of the forward reaction equals the rate of the backward reaction. This kind of equilibrium is also called dynamic equilibrium. It is useful to know how much of each substance, in particular the amount of products compared to the amount of reactants. A simple ratio from the balanced chemical equation gives us a number called the equilibrium constant. Any factor that can affect the rate of either the forward or reverse reaction relative to the other can potentially affect the equilibrium position. The following factors can change the chemical equilibrium position of a reaction: concentration, temperature, and pressure for gaseous reactants. Le Chatelier's principle helps to predict what effect a change in temperature, concentration, or pressure will have on the position of the equilibrium in a chemical reaction. Le Chatelier's principle states that when an external stress is applied to a system in chemical equilibrium, the equilibrium will change in such a way as to reduce the effect of the stress. In this experiment, the shifting of the equilibrium of an indicator, a complex ion, and an insoluble solid upon the application of different types of stress, example changes in concentration and temperature, will be monitored. And that's it. No matter how you feel, start where you are, use what you have, do what you can. Have a good day. Goodbye everyone.